Day 617 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again another day, another LeetCode problem where we're doing daily LeetCode problems. And today we have question number 712, minimum ASCII delete sum for two strings. The difficulty level is medium, but don't worry because you already know we're going to keep the solution as simple and easy to understand as possible. But before we get started, y'all, don't forget to like, hype, subscribe, comment, and share. And if you need any new Apple AirPods, go in and check out that link in the description so you can get you some. Now let's see what the question says. Given two strings S1 and S2, return the lowest ASCII sum of deleted characters to make two strings equal. All right, y'all, so that sounds pretty simple, but let's go ahead and take a look at these examples anyway, just to make sure that we are doing this problem correctly. So, in example 1, we have our input S1 equals a string C, SEA. S2 equals a string E, EAT. The output is 31. So, before we look at the explanation, let me go ahead and copy and paste this handy dandy ASCII table right here so we can see how much each letter is worth. And so we deleted, let's look at the explanation. It says deleting S from C adds the ASCII value of S, or lowercase s, which is 115. Let's check that, make sure that's right. Boom, right. So S is 115. Then we're going to delete the T from E, which adds 116 to the sum. So T has a value, ASCII value of 116. So we deleted a S and we deleted a T. Once we deleted both of those, the strings were equal, right? So what they mean by that is first we had C and then we had E. Boom. So we deleted the S. That was 115 right there. Boom. Then we deleted the T. That was 116 right there. And look, the strings are equal. They are both EA. So that's what they mean by the strings being equal. And once we add those two together, we get 231. And 231 is the minimum possible sum to achieve this. So the output is 231. Now, just in case that didn't make sense, let's take a look at example 2. So in example 2, we have our input S1 equals a string delete, D-E-L-E-T-E, and S2 equals a string leet, L-E-E-T. This time the output is 403. So let me just go ahead and copy and paste these strings over here before we take a look at these examples. So boom. Put that string, put this string here, boom. So, explanation says, or before we take a look at this explanation, the explanation says deleting D from delete to turn the string into let. So what we're going to do, we're going to turn the string into let. So we're going to delete this D and this E right here. Now the string is let. Boom. So this is going to add, so we deleted D. Boom. So let's see. D. So D is going to be 100. Check the table. Boom. It says right here, D is 100. So we can just say D equals 100. Oh, we already have the table. Boom. So ain't no point in rewriting it. So D is equal to 100. Then we deleted the E. E is right here. That's 101. We deleted two E's, so that's two 101s to the sum. Then we delete E from leet, and that's going to add, so that's another E, that's another 101. And once we delete that E, once again, now the string is equal. So deleting E from leet adds 101 to the sum at the end. Both strings are equal to let. Boom, that's what we have right here. And the answer is 100 plus 101 plus 101 plus 101, which equals 403. If instead we turn both strings into leet or eat, we will get answers 433 and 417, which are higher. So remember, we want the minimum ASCII value to delete. So that's why we went with this one and turned these strings into let instead of turning these strings into eat, because we could have turned this string into eat and this string into eat, or we could have turned both strings into leet. We could have turned this string into leet, and we could have turned this string into leet right here by deleting the D, E, and the T, and right there, boom. But if we would have did that, once again, the answers would have been 433 or 417. We got a smaller answer by turning these strings into let, and that answer was 403. So that's the output that we were looking for. So now that we understand the question, y'all, let's get into the fun part, the actual solution. Solution is not that difficult at all. Now let me go ahead and delete this for y'all real quick so we can get into this solution. Boom. Now, the first thing we want to do, we're going to create our DP array. So we're just going to declare a variable called prev_row. We're going to set that equal to an array of integers. And we'll just open up the parentheses. It'll be repeating, colon, 0, comma, count, colon, s2 dot count plus 1. Boom. Then we're going to convert the strings to arrays of Unicode scalars so we can easily access the ASCII values and index characters. So we're just going to say let s1 equal, that's going to be an array, open up the parentheses, s1 dot Unicode scalars, just like that, boom. Then we're going to do the same thing for S2. So we could come down here, say let S2 equal an array, open up the parentheses, S2 dot Unicode scalars, boom. Now we need to handle the base case. If S1 is empty, then we must delete all characters from S2 to make it equal and then accumulate the ASCII values of the S2 characters. So for that, we could just say for j in 1 dot s2 dot count. We can open up the brackets. We can say prev row square bracket j. Come outside of that square bracket equals prev row square bracket j minus 1. Sorry, y'all, equal white space plus int, sorry, y'all, int, open up the parentheses, s2 square bracket j minus 1, come outside of that, dot value, just, sorry, y'all, that should say value, just like that, boom. Now we're going to iterate through the characters of S1 by coming underneath this for loop. We're going to start another for loop by saying for I in 1 dot S1 dot count. We can open up the brackets and we can start a new DP row for the current I. So we're going to say declare variable current row, set that equal to open up the square brackets prev row square bracket j minus 1. Come outside of that, we're going to say plus int, open up the parentheses, s2 square bracket j minus 1. Come outside of that, and we're going to say dot value. Boom, just like that. Now we're going to iterate through the characters of S2. We're going to come underneath that, and we're going to say for j and 1 dot S2 dot count. Then we're going to open up the brackets. And if the characters match, then no deletions will be needed here, so we can just carry over the diagonal value by saying if S1 square bracket I minus 1 equals S2 square bracket j minus 1, then we could come right here, open up the brackets, and we could say current row dot append, open up the parentheses, prev row square bracket j minus 1. Boom. Then we can come right here and we can say else, open up the brackets. Otherwise, we could just choose the cheaper option. So we could just say current row dot append, open up the parentheses, min, open up some more parentheses, prev row square bracket j, come outside of that, plus I and t, open up the parentheses, S1 square bracket I minus 1, come outside of that, dot value, then come outside of that parentheses right there, and we're going to say comma, current row, square bracket j, j minus 1, come outside the square bracket, plus I n t, open up the parentheses, S2 square bracket j minus 1, come outside that square bracket, dot value. Boom. Then we need to move the current row into the pre-row for the next iteration by coming right here, and we are going to say pre-row equals current row. Boom. Then we could come underneath that, and the last cell contains the minimum ASCII delete sum to make both full strings equal. So we just come right here and we say return pre-row dot last exclamation point. Boom, y'all. That should be all she wrote. Let's give it a run. See what it's looking like. Okay, we have an error. Cannot find J in scope is crazy. Okay, so hold on. One moment, y'all. So sorry, y'all. This should be pre-row. Let's turn this to a 0. Boom. Then we're going to say, and we're going to turn this to an I. Sorry about that, y'all. Now let's give it a run. See if that did the trick. Okay, let's see. See what it says. Does it say anything? No. So they gave us this crazy error. So let's see if we can figure out where we went wrong. Shouldn't be that hard to find. Give me one moment, y'all. Oh, this right here should be S1, y'all. This should be S1. Now let's give it a run, see if that did the trick. Yep, there it is, y'all. So now let's go ahead and submit it. Make sure it's still accepted after we submit it. Let's see, it's accepted, y'all. Look at that, y'all. 5 milliseconds beats 100% of users. That's what I'm talking about. That's what I'd like to see. So before we go, make sure you get one more look at the code. This is the top part. This is the bottom part, y'all. And yeah, with that being said, I hope y'all learned something today, and I hope to see y'all here tomorrow for another day, another LeetCode problem. See y'all then.